Hello everybody, welcome into Solving Radical Equations Part 2. This lesson we only have a radical expression on one side of the equation. These actually aren't that bad either, but like in the last lesson, you still have to check for extraneous solutions. So here you have the square root of x equals 1/9. Well, it's going to be relatively the same as what we did in the last lesson. If you have a radical on one side, for instance, the square root, you still have to raise both sides to the second power. So if you do that, you'll literally get that x equals 1 to the 81st. I'm sorry, 1/81st. But you got to check for extraneous solutions. So if you put in 1/81st, the square root of that, you would get 1/9. So in this case, that was fairly obvious that that'll work. So x would in fact be 1/81, but sometimes it's not going to be that obvious. But I do got more. Okay. Let's see, the cube root of x plus 10 equals 16. So we have the cube root of x plus 10 equals 16. Well, I'm going to suggest first we get that cube root of x by itself. So subtract 10 from both sides. You'll get the cube root of x is equal to 6. Now just raise both sides to the third power. You would get x would equal 216. And if you put in 216 for the cube root of x, you would in fact get 6, so 6 plus 10 equals 16. So that also checks out. You get an x value of 216. Just got to verify your work. Alright, now we have the fourth root of 2x minus 13 is equal to -9. Well, I would get that fourth root of 2x by itself, so the fourth root of 2x, add 13 to both sides, you'll end up getting 4. So the fourth root of 2x equals 4. Now just raise both sides to the fourth power. You would end up getting 2x is equal to 256. Which would give you x equals 128. But let's check our work. Well, alright, so 2 times 128 is 256. The fourth root of 256 is 4. 4 minus 13 equals -9. It checks out. So x equals 128 would actually be the solution in this case. Alright, so we have the square root of x plus 56 equals 16. So the square root of x plus 56 equals 16. Well, you're definitely going to want to square both sides, so if you do that, you'll end up getting x plus 56 equals 256. Then solve for x, you would just get that x equals 200. Now put that 200 value in for x. Square root of 200 plus 56 equals the square root of 256, which does in fact equal 16. So the x value of 200 is the solution for this particular equation. Alright, now we have a cube root of x plus 40 equals -5. So we have the cube root of x plus 40 equals -5. Since this is an odd power root, it is possible to have a negative number for your answer. So basically the domain of x is all real numbers since this is an odd power root. So raise both sides to the third power, you would get that x plus 40 is equal to -125. solve for x, you would get that x equals negative 165. So if you put that into your cube root here where the x is, you would get negative 165 plus 40 gives you the cube root of negative 125, which is negative 5. So that x value of negative 165 does check out. That would actually be the solution. Alright. Now here's a good one. Is that what it is? Nope. Good thing I looked at it here. Alright, so we have the square root of 6x minus 5, all that plus 10 equals 3. Well, you definitely want to get the square root by itself, right? So subtract 10 from both sides. You'll get the square root of 6x minus 5 equals negative 7. Well, here's the thing. The square root of a number will never be negative, right? Never. So right there, we're done. You got no solution. There's actually no solution to this since you would end up having... Now, okay, yes, you could square both sides. You would get 6x minus 5 equals 49. And you then get 6x equals 54, where x would equal 9. But you would end up getting that the positive square root of 49 equals negative 7, which would basically be saying that positive 7 equals negative 7. That's not a true statement. So there's really no solution to this. Not at all. Alright, let's spice it up a little bit. We have 2/5 times the square root of 10x plus 6 is going to be equal to 12. Well, I think it's safe to say we want to get that square root by itself, right? So multiply both sides by 5 first. You end up getting 2 times the square root of 10x plus 6 is equal to 60. Okay, and then divide both sides by 2, so the square root of 10x plus 6 would equal 30. Now just square both sides, you end up getting that 10x plus 6, 30 squared is actually 900. So you would end up getting 10x plus 6 equals 900, which would give you that 10x equals 894. So let's simplify this then. Got to divide both sides by 10, that's true, but 894 and 10 both have a common factor of 2, so you'd end up getting 447 over 5. So it looks like we got that x equals 447 over 5. Well, basically now this is going to come down to a decimal approximation. So let's see what we get here. So, all right. So let's see, let me write in the other color. So take 2/5 times the square root of 10 times 447 over 5 plus 6. Would that equal 12? Well, this would turn into 2/5 times the square root. All right, 10. All right, so the 5 cancels out. You would get 2 times 447, which is 894. 2 times the square root of 894 plus 6 would equal 12. Okay. So then take 2/5 times the square root of 900, which would equal 12. Well, what is the square root of 900? That's 30. 2/5 times 30. Set that equal to 12, and 2/5 of 30 is 12. So yes, 12 equals 12. We have a true statement. So the value of x in this case is 447/5. So that was not a pretty solution, but it works. That's the actual solution. And no one said this was always going to be pretty, that's for sure. All right. Two times the square root of 7x plus 4 minus 1 is equal to 7. So we have 2 times the square root of 7x plus 4 minus 1 equals 7. Well, let's go ahead and get that 2 times the square root of 7x plus 4 by itself. Add 1 to both sides. So you'll get 2 times the square root of 7x plus 4 equals 8. Now we can get that square root of 7x plus 4 by itself. Divide both sides by 2. You would get the square root of 7x plus 4 is equal to 4. Now you just square both sides. You'll end up getting 7x plus 4 equals 16, which would end up giving you that 7x equals 12. Okay. So then this would give you that x is equal to 12/7. But let's see if that checks out, if 12/7 is actually the solution. So 2 times the square root, let's see. 7 times 12/7 is literally just 12 plus 4. All that minus 1 equal to 7. Well, this would turn into 2 times the square root of 16 minus 1 equal to 7. So 2 times 4 minus 1 equal to 7. 8 minus 1 equals 7. And then 7 equals 7. So we got a true statement on both sides. That means that x does in fact equal 12/7. That is the solution to this one. Again, not the prettiest, but you will get answers like that sometimes. Here's a good one. So -2 times the 5th root of 2x minus 1, all that plus 4 is equal to 0. So -2 times the 5th root of 2x minus 1 plus 4 is equal to 0. Well, let's get that -2 times the 5th root of 2x minus 1 by itself first. So subtract 4 from both sides. You'd end up getting -2 times the 5th root of 2x minus 1 would equal -4. Now you can divide both sides by -2. You end up getting that you get the 5th root of 2x minus 1 is equal to +2. Now, of course, you just got to raise both sides to the 5th power to cancel out the radical. You end up getting 2x minus 1 would equal 32. So this would end up giving you that 2x equals 33, giving you an x value of 33/2. All right. Does that work? Does this actually work? Well, to make your life easier, we could put it into the simplified equation here, the 5th root of 2x minus 1. So let's do that here. So let's see, the fifth root, so 2 times 33 halves is literally 33, then minus 1. Set that equal to 2. Well, this turns into the fifth root of 32. Set that equal to 2. Well, the fifth root of 32 is 2. So 2 equals 2. That is your solution then. So x would have a solution of 33 halves. That would be the solution to this problem. I have about 5 more, then we're done. This is a good one. X minus 12 equals the square root of 16x. So x minus 12 equals the square root of 16x. It's actually nice and convenient that that 16 is under the radical sign, because we're going to have to still raise both sides to the second power to cancel out the square root, right? So you would end up getting the quantity of x minus 12 raised to the second power would equal 16x if you raise the second side to the second power, which this will simplify then into x squared minus 24x plus 144 would equal 16x. Okay. Now let's simplify this more. You'd end up getting x squared minus 40x plus 144 would equal 0. So we have a resulting quadratic equation. Now, checking for extraneous solutions is going to be very important because we have a resulting quadratic equation. So, are there any factors of 144 that would give you negative 40 in the middle for your coefficient? Well, let's see. 144 divided by... No, let's see. Yes, you actually have 4 and 36. So this would literally end up turning into the quantity of x minus 4 times the quantity of x minus 36 equal to 0. If you FOIL this out, you would get x squared minus 40x plus 144. So now, of course, you set both of these solutions equal to 0. What are you going to get? You're going to get that x equals 4. You're also going to get that x equals 36. But here's the thing. We need to check both solutions. We got to check both. So let's put in x equals 4. So if you put in x equals 4 here, you would end up, let's check that with a blue marker. You would get 4 minus 12 equals the square root of 64, which would mean negative 8 equals the square root of 64. Well, just the plain old square root of 64 is 8. That would be saying that negative 8 equals positive 8, which it definitely does not, right? It doesn't. So that means x equals 4 actually has to be thrown out. X equals 4 is what's called an extraneous solution. But let's look at x equals 36. So put in 36 minus 12, set that equal to the square root. Well, square root of 16 times the square root of 36. Right? 36 minus 12 is 24. That's going to equal 6 wait, what am I saying here? 4 times 6, which means 24 equals 24. So x equals 36 is actually a viable solution. In fact, it's the only solution to this one. So x equals 4 is an extraneous solution, meaning that it's not a viable solution. So the only viable solution is x equals 36. This is where checking for extraneous roots is very, very important. Otherwise, you might get a wrong answer. All right, let's see. We have the fourth root of x to the fourth plus 1 is equal to 3x. Well, we definitely want to raise both sides to the fourth power, right? So, you do that, you'll end up getting x to the fourth plus 1 would equal 81x to the fourth power. So we have a bit of a mess here. This ends up turning into 80x to the fourth would equal 1. So now let's take 80x to the fourth minus 1, set that equal to 0. Well, interesting thing here, this is a difference of two squares, right? In theory, we could have 4 solutions, but I can tell you right now, 2 of them are about to be imaginary. Because, let's see, you take the square root of 80, it turns into the square root of 16 times 5. So what you'll end up getting is 4 times the square root of 5, x to the second plus 1, times 4 times the square root of 5, x to the second minus 1 would equal 0. Alright. Well, we know for a fact we can discard the left term, right? Because we'll just have imaginary solutions. That's not what we're looking for. But here's the pain in the butt. We can totally break down the right term into this is a difference of squares, so it'll factor further. You'll end up getting the square root of 4 is 2, the square root of the square root of 5, so you'll end up having 2 times the fourth root of 5, x plus 1 times 2 times the fourth root of 5 times x minus 1, all that equal to 0. These are the only 2 we can look at now, since they're going to produce real numbers. Alright, well, let's set each of these equal to 0. I promise you it's not going to be very pretty. So let's take, let's see here, 2 times the fourth root of 5 x, set that equal to negative 1, you end up getting x equals negative 1 over 2 times the fourth root of 5. So let's check that solution. If you put this into the radical, you'll get a positive number, right? Because a positive number, a negative number to the fourth power is always positive, right? But, look at the right side. That would be saying that the fourth root is equal to a negative number, which we know isn't true. The fourth root would always be positive. So this solution actually gets discarded. So now our only hope is 2 times the fourth root of 5 x equals 1, which would have to mean that x equals 1 over 2 times the fourth root of 5 So we have to check the solution though. So let's put this in here. So we'll have the fourth root of, let's see, so 1 all over 2 times the fourth root of 5 raised to the fourth power. That'd be 1 over 16 times 5. All that plus 1 equal to 3. Well, this would turn into the fourth root of 1 over 80 plus 1 would equal 3. So then you'll have the fourth root of 81 over 80 equal to 3. Well, wait, I'm sorry. 3 times... I wish it were as simple as 3. 3 times 1 over 2 times the fourth root of 5. I knew I was forgetting something. So 3 times 1 all over 2 times the fourth root of 5. That's going to make a big difference, which would simplify into 3 all over 2 times the fourth root of 5. Alright. Well, good news is fourth root of 81 is 3, so this would be 3 all over the fourth root of 80 turns into 2 times the fourth root of 5 would equal 3 all over 2 times the fourth root of 5. So this last solution here checks out. X would equal 1 all over 2 times the fourth root of 5. A very hideous solution, but that is the solution. I have 3 more. Alright, square root of x squared plus 5 is equal to x plus 3. So square root of x squared plus 5 equals x plus 3. Okay, so we got to square both sides. You do that, you'll get x squared plus 5. That would equal the quantity of x plus 3 raised to the second power. So you would get x squared plus 5 would equal x squared plus 6x plus 9. Okay, so good news is the x squareds go away. So this would literally turn into 6x would equal negative 4, which would mean that x equals negative 2/3. But is this a viable solution? That's what we need to find out. That's exactly what we have to find out. So put these in for your x values, okay? So negative 2/3 to the second power is 4/9. Then plus 5. Set that equal to negative 2/3 plus 3. So this would give you the square root of 4 plus 45 all over 9, which would end up, negative 2/3 plus 9/3. So this would turn into the square root of 49 over 9 would equal 7/3, which would give you 7/3 equals 7/3. That is, in fact, true. So this x solution of -2/3 does check out. X does, in fact, equal -2/3 in this case. I have two more. Alright, the square root of 8x plus 1 is equal to x plus 2. Not too bad. So the square root of 8x plus 1 equals x plus 2. So let's square both sides. If you do that, you get 8x plus 1 equals the quantity of x plus 2 raised to the second power. So that's going to give you 8x plus 1 equals x squared plus 4x plus 4. So now this would end up giving you x squared minus 4x plus 3 equals 0. Well, what factors here? How does this factor? This is going to factor into the quantity of x minus 1 times the quantity of x minus 3 equals 0. So now we have to, of course, set each of these factors equal to 0. That'll give you x equals 1 and then x equals 3. This is where we got to check for extraneous solutions. So set each of these equal to, put x in for each of these. So let's see, 8 times 1 is 8 plus 1. Square root of that would equal 1 plus 2. That gives you the square root of 9 equals 3, and 3 equals 3. That checks out. So x equals 1 is a viable solution. But what about x equals 3? So this would give you, see, 8 times 3 is 24, plus 1 would equal, and 3 plus 2. So that's going to give you the square root of 25 equals 5. Square root of 25 is 5. 5 equals 5. So x also equals 3. So you actually have two viable solutions. X equals both 1 and 3. I think we'll actually leave it here, folks. It's pretty much the same type of example for the next one. So the next lesson will be the final in this mini-series. It's going to be about solving rational power equations. So I hope everyone has a great day. Take care.